Good morning everyone. So today we are going to discuss about LVDT transducer, construction and working of the LVDT transducer. Before going to the construction and working of LVDT transducer, so first, what do you mean by LVDT transducer? So transducer is a device, it converts mechanical energy to electrical energy. It converts mechanical energy to electrical signal. So it converts one form of energy to another form of energy to another form of energy. So LVDT means linear variable differential transducer. I am repeating, LVDT means linear variable differential transformer. So this is the one type of transducer, linear variable differential transformer. So one type of transducer, it measuring displacement. So this displacement measurement by using LVDT transducer. So in this LVDT transducer, it consists of primary winding and two secondary windings. So here we have, you may observe in this diagram, it consists of one primary winding and two secondary windings. So we are giving supply to this primary winding. Then so here in between we have a armature core will be there. So that ferromagnetic core. So at the end of the core, so in the left side we have a arm of the core. So here the physical quantity, where the physical quantity is to be measured, so that will be connected the displacement, where the physical quantity, whatever quantity we need to measure, that will be connected to this armature arm of the armature core. So here the displacement will be converted into the electrical signal. So in the secondary winding, so the few conditions must be satisfied. So in order to get a few conditions must be satisfied. So the first one, so these E1 and E2, secondary winding 1 and secondary winding must be connected in series. Secondary winding 1 and secondary winding 2 must be connected in the series. So second point, so the number of turns, secondary winding 1 and secondary winding number of turns should be equal. The number of turns for secondary winding 1 and secondary winding should be equal. So the secondary winding, another important parameter, the secondary winding 1 and secondary winding 2 also equally placed the distance placed equally. Secondary winding and secondary winding 2 must be placed equally. So these are the three important parameters. So in order to satisfy, so the few conditions must be satisfied in this secondary winding. Few conditions must be satisfied in the secondary winding. So what are the three? So secondary winding 1 and secondary winding 2 must be connected in series. Then secondary winding 1 and secondary winding turns, number of turns should be equal, so it will be placed equally. So these are the three conditions to be satisfied in the secondary winding 1 and 2. So now we are going to see the construction of the, so the core will be connected in center position. So whatever voltage we are giving this primary winding, whatever voltage we are giving supply to this primary winding, so then core will be magnetized. So EMF will be generated. So the core will be ferromagnetic core. So this is the electromagnetic principle. So whatever we are giving supply to this primary winding, then core also will be get magnetized. So EMF will be generated, flux will be generated. So the armature arm of the core will be, so one end of the core will be connected to the where the physical quantity is to be measured. So where the physical quantity, so whatever what we are going to measure, the physical quantity, so displacement, pressure, force. So whatever the physical quantity we are measuring, so that will be connected to this arm of the core. So that will be one end of the core will be connected to the core of the arm of the core will be connected to this displacement where the physical quantity is to be measured. So now we'll see the working of this LVDT. So here we have three cases. Case 1, the core is in the center position. The case 2, the core will be moving towards left side, and case 3, the core will be moving towards right side. So now case 1, the core is in the center position. So we are giving supply to this primary winding, then core will be magnetized. So EMF will be generated, the magnetic flux will be generated. So here this will core will be in the center position. So whatever flux will be generated, that will be linked to the secondary winding 1 and secondary winding 2. So this magnetic flux will be related to the secondary winding 1 and secondary, more flux is related to the nearer to the secondary winding 1 as well as secondary winding 2. So in this case, so secondary winding 1 more flux will be linked to the secondary winding 1 as well as secondary winding 2. So here 1 minus 1 that equal to 0. So this is about null position. So that will whatever flux will be generated, that will be linked to the more flux will be linked to the secondary winding 1 as well as secondary winding 2. So this is about core center position. So this is about case 1. So now we'll see the case 2. So the core will be moving towards left side. The core will be moving left side. The core will be moving towards left side. This is the case number 2. So here, so we are giving supply to this primary winding, then core will be magnetized. So the more flux will be linked to the secondary winding 1 only. The more flux will be linked to the secondary winding towards, so the core will be moving towards left side. So the more flux will be linked to the secondary winding 1. So in this condition, secondary winding 1 is greater than to secondary winding 2. Secondary winding 1 is greater than to the secondary winding 2. So whenever core will be moving towards the left side, so the secondary winding, whatever the flux will be generated, that more flux will be related to the secondary winding 1. So secondary winding 1 is greater than secondary winding 2. So here 1 minus 0, so it gives 1, that will be the positive value. It gives the positive displacement value. So here whatever the displacement, so the core arm of the core will be connected to the displacement where the pressure or force or physical quantities to be measured. So that will be converted to the displacement into electrical signal. So in the case 3, the core will be moving towards right side. The core will be moving towards right side. The core will be moving towards right side. So that in that case, more flux linked to the this secondary winding 2. More flux will be linked to the secondary winding 2. So here secondary winding 1 is less than to the secondary winding 2. So secondary winding 2, this what is secondary winding 2. So what this is about 0 minus 1, that gives 1. So it gives the negative value. So whenever the core will be in the right side position, the more flux will be linked to the secondary winding 2. So it gives the negative value. So these 3 conditions, core is in the center position, second one is the core moving towards left side, and third one core is in the right side. So whatever the core will be there nearer to the windings, so more magnetic flux will be generated, right? So this is the construction and working of the LVDT. So now we will see the applications. So applications, LVDT is used to measure the physical quantities such as force. So the physical quantities such as the force, pressure, weight. So what are the physical quantities? So force, tension, pressure, weight. So these quantities first it will be converted into the displacement. After that, by using primary transducer, it will be converted. These physical quantities will be converted into the displacement. After the conversion of the displacement, that displacement will be converted into the electrical signals. So then it is used to convert the displacement into the corresponding electrical voltage signal. So these are the this is the working principle. So it will be mostly used in the industries as well as servo mechanism. So it is also used in the industry automation, aircraft turbines, satellite hydraulics. So it is also used in the industrial automation, aircraft turbines, satellite hydraulics. So these are the some of the applications of the linear variable differential transducer. So now we'll see why it will be calling as a LVDT. Why it will be calling as a LVDT. So here the applications, so first it will be converted into the physical quantities into the displacement. After that, displacement will be converted into the electrical voltage signal. So first it will be converted by using primary transducers. It will be converted into the physical quantities into the displacement. After that, displacement will be converted into the electrical voltage signal. So these are the some of the applications. So now we'll see the why it will be calling as a LVDT. Why it name it as a LVDT. So first, linear variable different. What do you mean by LVDT? Linear variable differential transducer. So L means linear displacement. L means linear. So it will be measuring linear displacement. So in the LVDT, so transducer it converts one form of energy to another form of energy. So this by using LVDT it measured by linear displacement, that is the number one. So then we have a transformer, it has a one primary coil, two secondary coils, so it has a AC input and AC output. So the working principle is similar to the transformer, the working principle similar to the transformer. So it has one primary coils and two secondary coils. So this is about a linear variable differential transformer. So this type one is the one type of transducer, linear variable differential transformer. The working principle is similar to the transformer. Then variable. So we have a arm will be moving position, center position. The case one is that will be in the center position, then arm will be moving towards left side and moving right side. So variable, it has a movable core. It has a movable core and fixed coils. It has a movable core. Core will be in the center position, that is the case one. Case two will be, it will be moving towards left side. Case 3 it will be moving towards a right side. Then we have a differential. So the output voltage is the difference between two secondary voltages. So secondary winding 1 and secondary winding 2. So the output voltage is the difference between two secondary voltages. So that's why we call it as a linear variable differential transducer. So L transfer the measuring of the linear displacement. So variable means we have a armature core that will be in center position, that will be moving. So it has a variable, it will be variable. It has movable core and fixed coils. And differential, so the output voltage will be secondary winding 1 and secondary winding 2. The output voltage will be difference between two secondary voltages. Then we have a transformer. So the working principle is similar to the transformer. It has a primary coil and two secondary coils. So that's why we call it as a LVDT. So by using the LVDT we need to measure force, tension, pressure, weight, right? So that will physical quantities will be converted into the first we convert the physical quantities into displacement. That displacement will be converted into the electrical voltage signals. So these are the applications and construction and working of the LVDT transducer. So this is a simple diagram of the LVDT transducer. So I hope you are understanding the concept, construction and working of the LVDT transducer.